I'm gonna live stream to a
Like just
I'm
record
gonna
it.
live stream to like an unlisted video so that Jack can watch it later, or like anybody else can watch it
Oh,
back later.
nice. So yeah,
Which means
cool.
that you guys need to give explicit consent.
That's fine. Sure. I
Okay.
think as well, we have a blanket policy that everything on the WARG server is subject to photos, videos, and audio recording. I mean, it's nice as well if you're like explicitly recording it, so I'm appreciative that you did that, but just a note that that is, like, at least in the new member onboarding package, when they officially sign on to being a member, that's something that every member should be acknowledging too.
Right.
Yeah, but I mean, I'm glad you're asking anyway, and I would encourage you to
Okay.
do so, just as an FYI.
Okay, understood.
Yeah.
Okay, I've made it so that I should be able to. Okay, well, I can't see Discord anymore, but that's okay. I can only see the call, which is by design.
Oh, can you not like exit back into the chat?
I can, yeah, I think, but I've just popped out the window so I can capture only the Discord.
Oh, I see.
Yeah.
Makes sense.
Oh God.
The one thing I hate about doing calls on mobile is that I can't adjust the music of my volume independently from like voice call music. Or
Right.
not voice music, like the sound of the voice call.
Right.
It's kind of annoying.
Okay. All right. This is very interesting. Okay.
Alrighty.
Cool. So, as it exists, this is the attitude manager sort of.
So this is as it exists.
This is essentially as it exists, or
Okay.
the way as it exists doesn't actually, like, there's no clear documentation on it. The closest we have is some old file from a long time ago that looks like this.
Yes. Okay. That makes sense.
And this is essentially what our attitude manager is. So this is like fetch instructions, this is get position, this is run controls, output mixing, and then these two have sort of disappeared. And then this one period of time check, I don't think exists formally. So it just goes back to here. And it runs through basically in this loop forever and ever and ever and ever. And
So is that, so then what's the difference between the flow chart and what is actually existing right now? Is it just like a few minor bugs, or like not this flow chart, the one that you made in Mermaid?
so I wanted to make the attitude manager less of like a while true loop and more of like an actual state machine with like to leverage the ability to go between states. And I wanted to leverage the ability to go into the state where you're not in fatal failure, but you don't do as many computations for whatever reason. So
Okay.
largely you go fetch instructions, you get position, you do your PIDs, and then you do your output mixing, and then you go sort of back. And telemetry management isn't really telemetry management, it's more like state reporting. And so it just kind of just loops back around. And that's sort of what attitude manager would look like for ZP3 software if we wanted to largely keep the same structure and work off of existing code.
Okay. I had a few thoughts, but something that I want to get a better understanding of before I start spewing them out is I want to get an idea of what actually interacts with attitude manager on a higher on like the entire system level architecture, right? So
yes,
so I want to go a little bit higher up. Like I want to talk about where path manager fits in and what's actually happening, because I have a suspicion about what's happened to attitude manager, which makes architecture about this confusing.
Okay.
And but I want to confirm that by like walking through the current architecture, like basically what threads and like what managers do we have and how are they interacting with each other? That's what I want to know.
So I quickly threw this up earlier today because I thought it would come up.
Yeah.
So the three managers we have really, path manager, attitude manager, and telemetry manager. Path manager is the exact same as before. It gets incoming sort of requests for from CV for waypoints. It handles that path generation, and then it communicates to attitude manager. Basically, the next place it wants attitude manager to fly to. So you get an XYZ as a unit vector and a magnitude and a velocity target of how fast you want to fly towards that point.
Awesome.
That's been very like that. This is set in stone basically at this point. Because
curious, just really quick topic. What's if we already have heading magnitude?
Yeah.
How does the velocity target, like what do we use what's the difference between the two in this context?
The way I described it to Gordon is basically your magnitude. If I want to turn left, right? Like 90 degrees left. Your magnitude is going to tell you how far left your set point is, and your velocity target is going to be how fast you want to travel there. So if
go ahead.
If your point on the left is only like a short distance away, you might have the option to mix controls in a very different way. Or if your velocity target's a lot lower, you might have the option to mix controls in a different way. So if my velocity target, let's say, is like less than the airspeed needed to fly a fixed wing, then we would just choose to use the quadcopter controls. Whereas the magnitude is sort of how far left it is. So it gives you options to like maybe control the aircraft in a different way.
I'm still not fully like what I feel. If I understand it correctly, what's happening with velocity target is it's just an arbitrary number that we say this is how fast we should be flying through the air.
Yeah. So the velocity target isn't strictly necessary in cruise mode flight. In that case, magnitude is sort of the defining factor. This is used currently for auto takeoff and landing because we have fancy math that sets a velocity target.
Interesting.
And that comes from Gordon and his experience working with drones in industry. And in the future, if we ever wanted to limit our velocity across a certain section for whatever reason, like you have to fly through this area at a certain velocity, you could use this target to basically set a maximum or a minimum, or basically a target that you want to fly at.
Okay, all right. I think I understand it a little bit more when you mentioned the auto landing in there. Okay, sweet.
Yeah.
All right, cool. That is exactly what I pictured the PM, because like the way I picture path manager working is like path manager, like at least in my mind, shouldn't care whether it's a quad, whether it's like a fixed wing, whatever it is. Like it just knows of itself as just like a random like point in space, right? And it gives it a 3-dimensional vector and it follows it, which it seems like we're doing. Cool. I'm sold on that. What's the next big thing that we have there for like I see like 3 key threads that are happening.
So path manager just does your like waypoint handling, path management, look ahead, whatever you want to do, right? It just throws you a point for attitude manager to fly to. Attitude manager figures out how to fly there. Attitude also manages teleoperated control in the case that you wanted to bypass your autopilot system. So if I want to fly fixed wing, basically where in acro mode where my stick input correlates directly to control surface outputs, maybe with some rate or curve, it could do that. Or if I wanted to fly in stabilize mode where, I'm telling the plane, I want you to turn left using like at this radius, you could do that. Or you could say fly totally autonomously, or you could say, fly in like GPS hold mode where my stick commands you to fly to a certain point. And so attitude manager handles all of the like actual flying and keeping the drone in the air.
Okay.
And yes, it has a little bit of that like controls weirdness in there. Don't know if it should be a separate manager just yet, but we didn't want to put it in Path Manager or anywhere else, so we just put it in Attitude Manager and said, you know what, it can be there because it's related to the controls directly.
Okay. All right. You're hinting at what I'm about to propose, but I'm glad that at least we're having similar sort of thoughts. I'd like to discuss, like, in Telemetry Manager, at least my understanding is it's just its own thread, and like it just receives stuff and it just blasts it out, and you can pull stuff from it, correct?
Yeah.
Okay, sweet, cool. So you actually mentioned my thought, which is, or actually more accurately, what I suspected was happening to AM, because the original vision, I think we both, like, when you mentioned the vision, I think we both have it shared, right? Like, you receive, like, ideally, Path Manager or whatever, you basically give it like a 3-dimensional vector, right?
Yeah.
You give it, all right, and then Attitude Manager figures out how to take a 3-dimensional vector and match the aircraft's pose to it, right?
Mm-hmm.
Cool. So, real question is, with that, why is Attitude Manager? And so the question that I started asking is, why is Attitude Manager suddenly now caring about whether the drone is armed or disarmed? Why is it caring about whether we're like, why is it having to handle failures that are necessarily outside the scope of like flying the plane? Is the question I started asking, right? And then you mentioned it right there, because it was semi-related. It got put into what is just management of the aircraft's attitude.
Yeah, I'll also just quickly go back to, like, remember how before there was a safety chip and an autopilot chip? When we rewrote everything on safety, we scratched it all and just made safety as Attitude Manager, basically.
Yes.
And so everything related to safety, like arm, disarm, got worked into Attitude Manager, and that's been sort of just carried over and grandfathered in.
Okay, and that would make sense as to where that came in. Yeah. So, kind of my thoughts are, and I think I conveyed to you the initial thing about like a flight mode. Oh, and also you're gonna have to, like, I'll give a forewarning. I haven't touched this code base in like a very long time. Mm-hmm. Those state classes, like, so please correct me. Like I don't want this to be like I'm telling you this is how you should do it. I haven't touched this code base in a while, so you're gonna need to like, well, tell me if my understanding is wrong and like raise the alarm bells, because otherwise this isn't gonna be fun. Okay. But with that being said, like, what I was thinking about this is that, first of all, the Zero Pilot system is running in these like 3 key threads. Well, forget about telemetry for now, because like it's telemetry and it isn't like whatever, right? Like, yeah. We're like, it's Path Manager and Attitude Manager's interaction that we're concerned with, and how Attitude Manager operates. Like, I think given the bloat that has happened in Attitude Manager, I want to first say, okay, we have nothing to manage the overall system state. We're putting it in Attitude Manager because of it, if that kind of makes sense, right? Like, the state of whether we're armed or disarmed isn't related to the command and control of an aircraft. Would you agree or disagree with that statement?
I would be inclined to disagree, because if we want to disarm the drone for whatever reason, we need the motors to turn off fairly quickly, and we never want that to fail.
If you want to turn off your motors fairly quickly, there's ways of doing that through real-time design, right? Or like, you know, we can, like, there's like ways of turning off your motor can be done very fast. That's not like, that's there. I'm talking about more from like just a very stateful perspective. Like, let's ignore the real-time consideration. Let's just consider this for like states. Is it the responsibility of something that determines the attitude of an aircraft to care about whether it's armed or disarmed?
No. It's not.
Sorry?
Yeah, sorry, continue.
Okay. No, I'm curious to hear your thoughts throughout all of this as well. That was an invitation for you to talk.
I'm thinking, I'm processing, brain lag.
Okay. Oh, good. I'll continue with kind of what I was about to say.
Okay.
I'm sorry, unless that was something you wanted to say.
No, I'm just stuck on this idea of like, I'll let you talk first because I think you're about to answer my question.
Okay, sweet. So what I'm about to say is that what I think is missing right now in the zero pilot system is basically something to manage the zero pilot system state. So things like whether we're armed, whether we're disarmed, whether we're in a fatal failure mode, all of that kind of stuff is the zero pilot system state, right? You can think of the zero pilot system state as just like just the state of zero pilot itself. Mm-hmm. Is zero pilot armed? Is zero pilot disarmed? Is zero pilot errored out? Not whether attitude manager itself is errored out. It's right now we're talking about, is zero pilot armed? Is zero pilot disarmed, right? The overall state of the system.
Right.
What I think is probably going to be better and make this more scalable, and the solutions I'm trying to propose are aimed at reducing the amount of code and bloat and legacy architecture you have to port, because if we do it right, you can kill off about 40% of the code base. Because 40% of the code base has turned into this bloat that maintains the state machine. But what I think we can start to look at is let's rebrand attitude manager in its current architecture as more like just a zero pilot. This is zero like zero pilot core or similar. And what I can imagine this core system doing is basically managing the state of zero pilot. So this is what takes care of whether we're armed, whether we're disarmed. And because it's the system, it can be as stateful as it wants. It can know everything, if that kind of makes sense, because it determines the state of the entire program, if that kind of makes sense.
Yeah.
And what I can see this doing is, we can pull a lot of logic out that's inside attitude manager, right? If you go back to the mermaid diagram, or the mermaid diagram you drew, what's actually missing in a lot of here is, say we error out in run control mode, or say we error out in any of these modes that don't have a direct line to error. You now have to draw all these lines into an error state, right?
Yeah.
Instead, it should be the responsibility of a higher level state. Instead, because an error state is common to everything, it should, or mostly everything on like these kinds of signs, it can be better said that, okay, let's run this in a higher level state machine that's responsible for the whole system, and then it can delegate those errors as required. This also means that you can like the states that I can anticipate going in there are armed and disarmed, right?
Yep.
The type of instructions you want to do. As you mentioned, if you want to operate this drone in completely manual mode, this zero pilot system can do it. It can run an entirely different flight model, or, well, what flight model is going to be renamed to? Well, flight model is literally attitude manager in this particular context.
Yeah.
But fatal failure mode would also live in this zero pilot system, right?
Right.
Communication with telemetry manager is also ripped out of there. Because, truth be told, does it have to do with command and control of the aircraft's attitude? No, it doesn't, right?
Mm-hmm.
Anyways, that is kind of like that's kind of what I've been thinking of. I'm curious to get your thoughts, what your question was, initial reactions, random outbursts.
Yeah, so my initial reaction was stuff like, you have in attitude manager, the old attitude manager, some stuff like getting instructions from the user that tell you to like arm or disarm the drone, right?
Exactly.
And so I was pretty sure we're just gonna move that to system state, and then you leave attitude manager as this flight computer that really just cares about where to go and how to get to that state. And that basically means that it makes more sense to have zero pilot do things like arming, disarm, autonomous, or control takeover, and then just calling attitude manager in the right way to make that happen.
Exactly. This architecture moves us exactly in that direction, right? Because, truth be told, attitude manager doesn't care about whether what's or more accurately, it shouldn't care what's calling it.
Yeah.
It shouldn't care about whether it's armed or disarmed, because guess what? If we're disarmed, we just don't call attitude manager under this architecture, right?
Yeah.
We just literally spool up, and we just keep on sending the motor disarm command inside the state, and then we're good to go. And then we don't have to worry about, and the other thing that this also does is that I mean, realistically, some of these states are going to end up being ported over all the way there, right? But
Yeah.
this massive event loop that you have going on the right, let's ignore the limp mode arrow. Let's ignore the limp mode arrows from now.
Yeah.
You have that primary like loop of get position mode, run controls, one output mixing
Yeah.
mode, and that just turns into one function. And that function can literally be like 10 lines because it just calls a bunch of other stuff and passes into arguments to other
Yeah.
things. Those functions are going to be massive. But the actual like function of when you're in this like run autonomous state or run teleop state or whatever,
Yeah.
they can be like 10 lines long. They don't need to be complicated, right?
Yeah.
And like what I can see happening is that like fetch instruct, like let's pretend as though we go with this proposed architecture that I'm mentioning and we rename, and like this mermaid diagram, it turns into Zero Pilot 4 or whatever you choose to name it.
Yeah.
Fetch instructions mode I can see being renamed to run attitude manager. You can probably make a case for potentially splitting up into run teleop controls and run autonomous controls, and those basically call two different things. Or they could be the same with an if statement. That's like you would have this state. Apologies, I cut out for a second there. But you would have the state that runs at something alerts, like say we have like the semaphore that fires on anytime like a disarm GPIO goes high or whatever. Mm-hmm. And the next time this Zero Pilot core thing runs, it sets into disarm, boom, we go straight into the disarm mode. Or if something errors, we go into the disarm mode or the error mode. And then from on there, we can do whatever. And then you don't have to turn this massive module into something that's very stateful about the rest of the system. It's just nice and isolated and will do exactly what you want it to do. Best part is it's also very testable, very scalable. Yeah.
Okay. So.
Yeah, go ahead.
My one confusion here, and that's probably just because I'm not familiar with the language. How do you get one state machine to control another state machine?
What do you mean? Like what do you mean one state? Oh, sorry, go ahead.
Like if I'm flying the drone and I need to disarm it in the air, how does, let's say, Zero Pilot Manager as a whole, the system manager, says, yes, hey, we're in disarm mode, stop the motor outputs. How does Attitude Manager get that information? Cool.
So that's a good question. Let's quickly sync up on the architecture before I answer that question fully. The system manager, as it would be, right? A system manager, if it receives a command to disarm, it's going to move itself to the disarm state. And what I see happening is for those architectures, we straight up don't call Attitude Manager. Attitude Manager is dead. It doesn't receive another iteration to be like, okay, process inputs. What we instead do is we just call a command that's like, or we just call our send motor command and we just send it all zeros. Because it's a system manager, it has the ability to do that. And you can just put it that way. Or more accurately, it's going to be like lost motor or whatever. It can straight up just call lost motor, just put it right there because it's a system manager. It's stateful. It can know about all of these things. And because we intentionally don't call Attitude Manager, we know that nothing else is controlling the motors.
So would you still have in its own thread Attitude Manager executing every however many cycles, however many like milliseconds or seconds or whatever?
Likely not, actually. Likely not. What is probably more than likely going to happen is like, so think of this current architecture, right? We're just think of it as more like a rename, and we're cutting out a lot of things and simplifying it along the way.
Yeah.
We're renaming it to System Manager. System Manager will run in its own thread that's running at whatever it is.
Yeah.
And only in a particular state will it actually call the flight model. But that is going to be running in its thread, right? Like the question is, the things that need to be running in their own threads are completely like async modules. Like sensor fusion is the perfect case of something that just runs in its own thread. You just pull it for outputs.
Okay.
Right? This is different in the sense that we want Mealy and More machines are a good example, but I forget which one's which. But you want it to be, this is a system that we want to be dependent on our inputs. And so we don't want it processing asynchronously, having control over the motors, and then have to like race condition it out of there. We want to be able to know this is exactly when we're calling our iteration of call attitude manager, do its thing, go from there. Because it's like the system manager, right? You can kind of think of it as like a kernel on top. Actually, no, it's not a kernel on top of a kernel, because Path Manager may be running in its own thing. You could also make an argument that Path Manager should be, no, I'm not going to entertain that idea for lots of reasons.
No.
But yeah, like the system manages Attitude Manager, and then it can, I don't know, Path Manager start, Path Manager stop. It can create task handles, but yeah, I don't know if I answered your question at all. I'm started diving in my own thing.
That answered my question perfectly.
Okay, I most certainly was not perfect, but I'm glad I got the idea across.
Yeah, no, I was mostly just wondering, like, does AM stay threaded, or does the system manager call AM to compute?
Mm-hmm. There's a case you can make, like realistically, the case that you would want to make, you have to make a case for something to be threaded, right?
Yeah.
It shouldn't be like everything's threaded by default. And I mean, right now I'm struggling to figure out a case of why we would want AM to be threaded when we have the system manager that's constantly just going through and doing its thing, right?
Yeah.
Yeah. And if I'm right, it should, you shouldn't be having to rewrite it from scratch. It's more of a rename, so everyone's on the right idea of what's happening.
Yeah.
Because your fetch instructions mode is kind of like, whether you like it or not, your fetch instructions mode is just turning into like a master, switch case statement,
100%.
which is not exactly ideal.
100%.
So, if you do it right, we can literally just turn this whatever fetch instruction state gets renamed to something more appropriate, run aircraft attitude. Whether you split into teleop or autonomous, or have an if statement that deals with that logic, you can make a fair case for either or and implement it however you wish. But at the end of the day, that function can literally just be 10 lines. Sensor fusion output, run the flight, and runs whatever this attitude manager thing does, and attitude manager done its thing, and go from there. What I'm trying to get at is Chris's point about breaking this module down into Legos is exactly the reason why I'm trying to hammer down all these modules as much as I can.
Mm-hmm.
If we can abstract it all, I mean, I mentioned flight models, but realistically, that's what Attitude Manager will turn into. It is just basically okay, it just runs, iterate once, give you motor outputs, and then just go, right? Attitude Manager itself becomes very simplified and becomes very generic that anything can call it. Yeah.
So your system manager needs to decide what inputs it's going to give to the flight compute attitude manager.
Precisely.
And then attitude manager.
Go ahead.
And then it would either be your teleop instructions or something from PM, or maybe some weird mix of both for some god awful reason.
Whatever reason, yeah.
And then the flight computer will take that information. Does a flight computer or the attitude manager choose how it wants to control the aircraft? I think it should. No?
What do you mean how it wants to, whether it has to choose between different flight models?
Yeah.
That's actually a good question. I think you can make a case for both. Whatever it is, I think as long as we have a base flight model class that is independent and in its own unit is going to be helpful no matter what we do.
Okay.
Realistically, because it's you're going to be making a fixed wing flight model, and you're making a quad flight model, as long as they both have the same interfaces, as long as we have that base class with the same interface, I think that's 80% of the work right there. Because if we ever want to reuse a flight model, boom, we just take the fixed wing flight model, we call that, right? The question is, what do we want to have that makes that distinction? You can do it two ways. The first is AM cares about AM cares about how the aircraft is flying and decides the flight model, or B, B, AM takes in a constructor. Oh fuck! Oh sorry, I'm at an airport right now and I saw someone bounce a landing.
Oh no.
Hard. Anyways, oh no, it's okay. They're okay. I think. Yeah. Yeah, and then the second thing is AM could be taking like a reference to like a flight to like another flight module class that like this higher level state passes in. You know how I said a few times, like you can make a case for breaking up like this master run AM state into either run teleop or run autonomous. I think it's a question of, if you want Attitude Manager to care about how it runs the flight models, you should not be splitting up the state and AM should just run. If you don't want AM to care about which flight model to run and it'll just blindly execute and like you just decide the flight model, then those states should be separate. Like they both have their pros or cons and you're gonna need to put that logic in somewhere. I'm low-key leaning towards putting it in AM, not gonna lie.
Yeah, I was as well. I think there's a few things that I'm sort of not super sure about, but I think if you do it where you split it up, it makes your work a little bit harder later on.
Example?
If I'm going between any sort of transitionary state between either fixed wing quadcopter or like teleop and autonomous, you might want to run both models at the same time and then be able to actually have something that does like a percentage mix of both of them.
Yeah.
And leaving that inside AM just I think makes sense because it's going to want both outputs and then mix it together to give you your desired output.
I'm trying to... sorry, go ahead.
No, I don't have anything else to say.
I'm just trying to think. The one last thing that I have is like your limp mode.
Yes.
I'm trying to think of a more generic case of, well, instead of... in my head, I'm modeling your limp mode as another flight model. Well, in this flight model, you just do zero computation, right? That's how I'm modeling this to keep it like abstract. Like I'm imagining like right now, if you have like a bunch of different flight models, you have one for fixed, you have one for quad, and then you have flight model manual, like the world has blown up, right? Which literally just maps your inputs to your outputs, but it keeps these same interfaces, right? What I'm wondering right now is AM, whether it should accept like a flight model selector array or like basically like the question I'm trying to debate internally right now is, if we move to an architecture that AM decides what flight model to run, should we add some sort of override to it that we can call to basically like negate AM and be like, yo, no, we want you to run X flight model instead? The only situation in which I can see that being used is in a pure teleop mode where we don't want to run something. A situation where we keep it in AM also means that we have to like rework. I mean, actually no, but you're gonna need to do that anyway. I was gonna say we'd have to rework the like get desired flight model function every time, but realistically that code is gonna be there everywhere. It's just a question of where you put it. Because say the next year we do some freaking like helicopter race car fixed wing thing, then well, boom, you have to rewrite that code anyways. And it's just a question of where we put it. Yeah, I think keeping it. What do you think? Do you think AM should have like some sort of override where it's like, okay, we can like manually like if this override is set, select a particular flight model, or if not, just like do its thing, right? I don't know. What do you think? What are your thoughts?
In my mind, the override was literally going to be screw the classes, screw everything. Like kill path manager, kill sensor fusion, like like stop like anything you don't need, just like stop it, and then like literally just do the percentage input from your stick and then set the capture compare register, or like PWM set basically. And the idea behind that is that if you have something like a hard fault or a reset handler go off for whatever reason, you don't immediately drop out of the sky, and you have a bit of time to either finish the task or like more gently land.
I'll hate to burst your bubble, but if we hard fault or reset handle, we're dropping out of the sky, no matter what you think.
Also, like in a case where for whatever reason, like sensor fusion stops working, like a wire gets unplugged, instead of going to fatal failure, you have a bit of time. I don't know.
Those are situations in which like the limp mode would be useful, but it won't be useful in a reset or a hard fault. That's actually exactly why we ditched the safety chip, was because that was the original thinking, until we realized, wait a second, like if your code seg faults or hard faults, like you're not going to be saving this thing anyway.
Tony mentioned a long time ago that maybe in the hard fault handler you could do something like that. So
you could, but in the hard fault handler, you assume the world has imploded. You can't count on anything. For all you know, it's your DMA buses that are busted, right? Like the last thing, like in a hard fault handler, that's exactly like you. Take a traffic signal, right? In a hard fault handler, all you do is you just blink GPIOs off and on, because it's the absolute simplest thing that you can do. You don't revert to some fixed traffic pattern. In our case, it would literally just be set the motors to 0 so that when we're in this hard faulted state, someone can grab this drone, right? Like in the hard faulted state, you assume the world has imploded and you do everything you can to bring your thing into a known state rather than putting it into an unknown state. Because if you hard fault again, your core will reset. And then you have no clue what, and then you have to deal with reset injection and all of that, right? Like say if your DMA bus gets fucked up for some odd reason, you hard fault because of it, you try hard faulting again, boom, well, now you reset, right? In which case you're no better off, and you also lost that statefulness of, and maybe your drone tries to do some, like, I mean, less ethical for us because we're going to be off, but you can imagine like on other devices where you do like a bunch of initializations, like you can imagine robots have like homing sequences and stuff, and that's bad. That's very bad. You don't want to do that. You would ideally just kill everything and try to save whatever last little, like whatever thing you have left.
Okay.
And shut it off, right?
Yeah.
But that's just a hard fault handler. Realistically, the cases that I think we're more worried about are like sensor fusion error and stuff like that. I think the more generic case is like once again, modeling it as another flight model. And this flight model just does no computation, right? Like it just shoots everything through, because it will do the exact same thing in your logic, right? Like if sensor fusion error is out, we override the flight model to this particular thing, boom, and just go straight through.
Yeah.
Sorry, go ahead.
So originally, the plan was to make all of the choices run in controls. So you would get into AM, you'd go into run controls mode, and the decision would be made there. Because for some reason that would leave everything else as generic as possible, and as little of the rest of the system had to change for like a new flight mode.
I mean, the rest of the system won't particularly change. Like, I mean, sure, you'll keep the same level of abstraction as long as it's contained to AM for which flight model to choose. The question I'm worried about is, the case I'm thinking about is if the pilot wants to put it in a VTOL mode, or if the pilot, or if you only want to fly it in VTOL mode, or if you only want to fly it in fixed wing mode, can we design an architecture to support that? Which is why I'm thinking of like, should we implement a feature where we can override our flight model?
Right. Okay, so let me think for a second.
Mm-hmm.
So I think for a VTOL aircraft, just to limit the scope of this discussion for now, you
Yes.
have quadcopter mode, fixed wing mode, and then you have this thing where you let it sort of automatically transition between the two. And you can theoretically select that using one of the 3 position switches. Is that enough control for the user?
Like, sorry, say the position switch thing again.
It's like quadcopter, fixed wing, or automatic transition between the 2. And so like that would be one position switch to choose how you want to fly the drone. And then you could have another position switch that goes between sort of acro, stabilize, and GPS, if it exists for that flight mode.
Yeah, so, yeah, like the question I'm wondering is like, I think it's less so about the operator interfaces, but then the question is, how do we expose AM to that in a way that's scalable?
I see what you mean.
Because your goal is to like, your goal with state machines, ironically enough, is to add as little statefulness into the states as possible. It's a very ironic concept, but it helps you write really scalable code because because you can write code that cares about literally nothing else, does its thing, and you trust it. But I guess this also makes sense. Like, it is the attitude. It manages the attitude. It is what flight mode we follow. Is the response is like directly there. I think maybe exposing an override might be the play. It is a little unclean, but I'm struggling to find an architecture that is cleaner. Because you don't use these during path manager mode, or maybe in the future we want to, like for auto landing. Actually, that makes sense. This also scales nicely for path manager, because in our auto landing and auto takeoff, no, but fuck, then it has to care about flight modes. Never mind. It should not be doing that in there. No, fuck. Because path manager shouldn't care. The whole thing that I'm trying to resolve is that path manager doesn't care. Maybe we just say that this is something only the teleop, like it's a feature that is only implemented for use with the teleop thing, and we just go from there.
Yes, you're gonna not like it. The the idea is that path manager just always computes what it wants to do next, and you choose if you want to use that or not. And so your ground station,
choose if it's what's sorry?
Yeah. So your ground station will tell you what path manager is thinking, right? And you could choose to do that, or you could choose to take control back to the teleoperator. But I think even when you're in teleoperator mode, you probably want to know what path manager is thinking if you're like getting ready to transition into autonomous flight.
Yes, I would. But the path manager doesn't care about the flight mode. That's all attitude manager.
Yeah. So
in this current architecture,
path manager is going to, I think, only get information from telemetry manager, which would be your waypoints and any special considerations you need to make for those waypoints.
Special considerations?
Like restricted areas or like speed limits.
Wait, what? Why is embedded doing that?
What do you mean?
Why is path manager having to worry about restricted areas?
It doesn't. It just like special considerations being like speed.
Okay.
Or like take off or land here.
Okay.
Or like
All right.
yeah. So
Okay.
so more like just like waypoint and waypoint type, I guess.
Okay. All right. I mean, it's beyond the scope of I think what we're talking about here.
Yeah.
But okay. Sorry, I was just curious. But yeah, go ahead.
And so path manager will always just compute based on that. And
Like, I mean, because okay, the crux of the problem lies in attitude manager is deciding something that we may want to also decide in teleop. That's the issue here. So we can either A, implement this externally of attitude manager and keep attitude manager like, and like that's why like that like I think that's why I'm saying maybe the two states argument would be valid. Like there's two ways of doing it. The first is attitude manager continues to decide, but we added override hooks into attitude manager. Or B, this system manager for zero pilot, when we're in teleop or the system manager decides the flight mode, and then it only executes that flight mode in a particular state. So you can imagine the teleop state, it just decides the flight mode based off of whatever controller switches there are, or in autonomous mode, it decides it just based off of like whatever calculations you would make. But the problem I have with that approach is that, well, now you just inherently have to do all this processing like in a system manager, which should not care about any of this. It should just care about calling some arbitrary function, which I mean, you could do, but I don't know.
I'm cool
I think
with,
maybe override hooks might be good.
I'm
Sorry,
cool
go
with
ahead.
override. I'm cool with override hooks with one master, sort of like boot AM kind of switch.
What do you mean master boot AM kind of switch?
It's just like arm disarm should not override something in attitude manager. I think it should be something that state manager manages.
Oh, absolutely. The system manager will be doing everything arm disarm.
Yeah.
Like that's why the system manager exists.
But I
you
think,
sorry, go ahead.
But I think other than doing stuff like arm disarm, you could pass all of the controls instructions to attitude manager and let attitude manager figure it out.
I think that's a good play. I think adding in override hooks. Yeah, I think adding in override hooks for that would be good.
Okay.
And I did also mention it, like path manager theoretically shouldn't care about it, but yeah, I really hate to say it, but like for things like auto landing, I mean, auto landing is actually very key. Yeah, wait, how the fuck do we have a generic auto landing sequence?
Ask Gordon.
That doesn't make any sense. No, but the auto landing sequence depends on whether it's a fixed wing or a quad. You can't use the same one for both. So path manager
You're
isn't generic.
right.
It does care about the flight model.
Hold on. No, wait.
Yeah, it does.
Unless you make the flight model something that system manager can initialize to be, so then it can choose which path manager auto land process it wants to run.
Fuck. Okay, so I think we have this all fleshed out. I think now now I'm curious, where would the auto landing fit in? Because you can make the argument that it's both. I still think path manager is the right place for it, but sorry, go ahead.
We decided to put in path manager because it integrates with sort of waypoint calculation very nicely.
Oh, 100%. I'm pretty sure I was the one that drove that call.
My,
To put it in Path Manager. I remember
Yeah.
convincing someone very strongly to put it in PM and not AM. But now what I'm wondering is how they did it without knowing the flight profile. Or actually, I mean, you're running it depending on fixed wing or quad. So maybe the override hooks do scale well. Because if you already have Path Manager that's keyed to the flight model, then you might as well just call the flight model directly. That actually works out. It's a little messy, but it works. It does work.
It does work, yes.
Yeah, I'm just wondering how. I mean, hey, it does work. I mean, yeah, because everything else in Path Manager doesn't need to care about the flight model. But auto landing and auto takeoff does. Because whether you're in a quad, whether you're in a helicopter, yeah, it actually makes sense.
Yeah.
Because, I mean, you can think about it, like, the auto takeoff sequence for a quad and the helicopter on the Path Manager side are identical, but you can imagine supplying an override being, okay, use the helicopter flight model. Don't use, like, don't, like, automatically determine which one to use and, like, yeet itself into, like, a cliff by accidentally firing up a fixed wing model. No, we override, use this particular flight model, and then we give it back to Path, and then Path Manager goes in. It doesn't bother specifying an override, and then it just determines it. It's messy as fuck, but it works. And I'm struggling to think of something better right now.
You know what? I was reading through some like open source flight software things. I think most of them literally just do hundreds of ifs for flight modes.
Yeah.
I
mean, honestly, sorry, go ahead.
And some of them do it like where in each stage you do like a case or 100 ifs. It's like in auto takeoff or landing, you'll do the whole like case statement. In cruise mode, you'll do all the case statement, not just for flight mode, but also for things like
actually, wait, it's
plane.
totally okay for Path Manager to know about flight modes. Sorry, go ahead. I interrupted you.
But then some other autopilots basically say your flight mode is what you initialize into. Your flight mode is your system manager. You can go between flight modes, but your flight mode will choose what else to call.
Like, what do you mean? What do you mean by what else?
It's like my flight mode would be like plane mode.cpp. And I would call plane auto takeoff landing, plane controls, and then my plane.cpp would understand things like how my user wants to control the plane and stuff like that. And then if we change modes, then we'll just exit from plane.cpp and go to like quadcopter.cpp.
Yeah. Which, I mean, we are actually doing. I mean, that's what's going to end up happening in this Attitude Manager class when we switch between flight models.
Right.
That's exactly what will happen, except
in this case, the plane itself, like the flight model itself, is a system manager that you just go to a different system manager.
Yeah.
Which might be kind of stupid if you need to do safety stuff, but.
See, the other thing is that, okay, so the other kind of like implicit decision here is like, how much code do we want to rewrite when we start? And I think with a solution that has flight model override hooks, the only thing you'll need to rewrite the flight model, the flight model itself needs to change, right?
Mm-hmm.
The algorithm that decides what flight model to choose needs to change.
Yep.
And for auto takeoff and landing, you just swap out like whichever flight like I'm imagining what will end up happening to make this really generic is like auto takeoff class and auto landing class that each have their own like generic things or whatever, and they can extend Path Manager's things or however you want to do it. I mean, realistically for right now, it's like, imagine just cutting the code that's intended for like fixed wing and implementing it straight for quadcopter, and just pasting in the code for quadcopter and just specifying the VTOL flight mode override.
Yeah.
And I think that can work. We're going to have to rewrite some code no matter how we port. And so like that's the thing with making it scalable is you can't make a system that's fully generic, because you have to make these up, because you have to like say that, okay, you're going to rewrite stuff at another time, or just compiler definition it out, right? But that's just how it is, I think.
Yeah.
Okay.
Hmm.
Yeah.
Chris is not going to like the idea of Path Manager knowing about flight modes and having overrides.
But I mean, the argument is it already does. Otherwise, how would you have an auto takeoff and auto landing system? Which is the conclusion that I came to, that it makes sense for it to have overrides because we already do it.
Yeah.
Like our architect, it's an implicit assumption that we all made, and it makes sense why we made it, because when you thought exercise it out, it's kind of like the reasonable conclusion to make. What I can see happening if we want to make this scalable is, like, as you mentioned, like instead of switch statements, I can just see us using compiler definitions. Like, okay, you might see this sprinkled in the old code, like if defined VTail, right? So we can do if defined quadcopter and if defined quadcopter autoland, compiling this code. Otherwise, compiling this code. And then inside this path manager, if we do auto landing, it's like you just compiler definition tree it, or you can if else tree it, but then it's just more flash space, if that makes sense.
Yeah.
But I
think it's an issue that'll come up in a little bit. We need to get stuff working first.
It'll come up later on. But realistically, given that, but you can already see like why it comes up later on. Look at these like you mentioned, you looked at like the other open source like stuff, right? It literally has all of this. Like it literally just has a bunch of if else's, and that is what our code will turn into. And we shouldn't be afraid of that, I think, because of the fact that what's his face? We shouldn't be afraid of that, because that's what other architectures that are generic and support multiple like flight models do. It does turn into it, right? Like I don't think that's something we should necessarily fear.
Yeah. I think the biggest fear that Chris has is that you have to end up rewriting stuff, but
you end up rewriting stuff anyway.
It's
trying to minimize. I think with this model though, you'll minimize a lot of what you rewrite, because everything is just contained to what flight model do you use, and a flight model itself, and nothing else needs to be touched.
Part of the consideration is not necessarily just how little it is that you need to rewrite, but how easy it would be for someone who's never seen this to rewrite something.
What do you mean by that?
It's just like there's a lot of people that are looking at AM and PM for the first time right now, and it's a lot. Right? There's a little bit of a lot of stuff to understand. Like you have to understand what a state machine is. You have to understand all of these states and modes. And like, maybe in the way that it is right now, adding in something only is like a few lines of code. It's not too bad. But to get to the point where you can add in those few lines of code takes a really long time. And we could probably save people a little bit of time when they have to first look at the code, even if it means they have to write a few extra lines later.
Sorry, I'm not understanding your, are you I'm not understanding your point particularly.
It's like the idea of, for us, I think, for not having to rewrite much code is it saves time. Right?
No.
Okay. See that, like Chris has been just talking about like not having to rewrite later and saving time and stuff.
So it relies on that assumption that is only true under the case that you have validated code, which we do not.
Okay.
So things that I anticipate you're not rewriting, sensor fusion. To my knowledge, that's something that is fairly robust. Am I correct in that assumption?
Yes.
I foresee you not rewriting that. That makes sense. Notice how we didn't really touch sensor fusion. You're just going to use sensor fusion output. Maybe you actually change it to use references instead of pointers.
No.
About last night.
No.
But aside from that, you're not really going to touch it. You can black box that module because it's validated. You only get to say we can reuse this code, and it's easier to do so if it's validated. Otherwise, you're going to get stuck with a very fucked architecture, as we have been. So you can only ever say that not rewriting code is going to be less painful if and only if it is validated code. Again, sensor fusion is a perfect example of something you wouldn't want to rewrite. It is validated code. We use it. We trust it. You really don't have much reason to like change it. Just call it its own thread and call it sensor fusion get output and call it a day.
Right.
Likewise, I mean, I'm not sure about the necessary state of path manager. I think you're being rewritten, but like again, right? In this entire thing, all we the real action items that come about in this architecture is we're renaming a few things. We're compressing our states actually instead of doing it. We're actually saving ourselves a lot of lines of code with this from a pure line perspective.
Yeah.
But the other thing that I'd also like to point out is that writing clean code, right? Like, I don't think we should you're a bit of a chicken or the egg problem here, right? First of all, it's much easier to write code than our code is read 100 times more than it's run. Like that's a big, philosophy number one of writing clean code, right?
Yeah.
Your code should be almost as readable as English. The second thing though is that you should not let, our code base should be easy to understand, be a driving factor in making architectural decisions. Because if you do so, then you're going to add this barrier that's like there, right? Like you're going to implicitly stick yourself down at the level of like a very basic C++ level instead of taking advantage of advanced design patterns. A state machine is a fairly advanced design pattern. It takes most first years a very long time to grasp it. Personally, it took me about 4 or 5 months to grasp like something what I now consider as a trivial state machine, but it's a fairly advanced design pattern. As we grow our knowledge as a team, the complexity of our code base is only going to grow no matter how much you try, because you eventually learn about all these nice things that you can pull. Like something that we're going to end up doing once we start taking advantage of C++ is all these nice modern C++ features, and it's going to confuse the shit out of the newcomers. But the thing is, you can use it to make your code a lot neater and a lot more scalable, right? I would say there's definitely a very distinct difference between writing clean code, right? We should always be striving to write clean code, but it should never, and making your architecture as simple as possible should be there, but you should never let like the consideration of how easy it is for someone to grasp just the literal how easy it is for someone to come in and understand your code drive how you architect something is just a point that I wanted to make, if that kind of makes sense.
That does make sense.
Yeah, I don't know, just something I wanted to mention. Like we should most certainly be writing clean code. Like I think you've heard me in this like I think you've probably heard me like when I say when I architect, like you keep it as simple as possible. And that's very true. But I don't consider how easy it is for someone else to understand, for like a newcomer to understand it, because that's not a requirement of the system. The system's requirement is it needs to work. The system's requirement is not, it's easy for people to understand, right?
Right.
Or easy for newcomers to understand.
That makes sense.
Yeah. I don't know.
All right. Okay. I gotta go soon. So, summary.
Okay.
Attitude Manager as it stands, is really should be a system manager. We give the new attitude manager, which is basically like a flight compute mode thing, and
Yes.
path manager overrides so that they know sort of what flight mode we're in, and then attitude manager.
You don't give path manager the overrides. Path manager knows that it has access to overrides, but attitude manager itself contains the overrides. Like, yeah.
Okay, and so path manager has them. Attitude manager actually decides to use one of them on its own.
It can, or it obeys the overrides, right? So
Yes.
if it sees an override, it runs that particular flight model or models.
Yep.
If it doesn't, it determines it on its own.
Okay. And then path manager only has the overrides.
Path manager can override if it wants to.
Okay.
Which also, like, what I'm imagining is going to happen onto that struct is, because like, you'll know you're on the right track when you can use the same struct to send data from attitude manager as it's the same data as if you were commanding it from your controller, right? And so in this case, you can imagine our controller. On our controller, we have those like 3 switches or whatever, right?
Yep.
Our controller has like a knob for flight mode override. And so you can also imagine like that data point should be identical, whether it's coming from a controller or from path manager. And so path manager can, in this message, set an override.
Okay. Makes sense.
Yes.
And don't do stupid things in hard fault handlers.
Yeah, in a hard fault handler, kill everything, kill all your motors, and just log it somewhere. Log it to the SD card, and then call it a day. Because you don't want to get caught in the case, because if you put yourself in a hard fault handler twice, boom, you reset, and then you have no clue what's going on.
Okay. All right. Thank you so much, Sahil.
No, thank you, dude. You're doing an amazing job doing all this, and you're the one that has to do all the work. I should be thanking you, not the other way around.
All right. Good night.
Good night. See you, dude. Good luck
See
on
ya.
midterms.
I'll do my best. Bye now.
Bye.